final rule that we're adding to our proof system is the existential elimination rule. Let's work through an example. So suppose that we have the premise for all x, if LJX, then LMX, anyone whom James loves, Magnolia also loves. And the premise, there is an x, LJX, there is someone that James loves. From those premises, it follows that there's someone that Magnolia loves. There is an x, LMX. But how do we demonstrate that? Note that the conclusion doesn't follow from the first premise alone. To conclude that Magnolia loves someone, we need the extra piece of information that there actually is someone that James loves. So we need to use the information contained in the second premise. The existential elimination rule allows you to draw conclusions from existentially quantified statements like that one. Now, before we go any further, let me remind you of how disjunction elimination reasoning works, because you can see yourself as doing something very similar when you use existential elimination. In disjunction elimination reasoning, you start with a disjunction, alpha or beta, which tells you that at least one of those two statements, alpha or beta, must hold. Then you show that each of those statements, both alpha and beta, would lead to a certain conclusion gamma, which then allows you to conclude that gamma must hold. Now, note that that same form of reasoning would work even if there were more than two options, as long as each option still led to the conclusion gamma. For instance, if you start with a disjunction of 5 different options, so at least one of the 5 options, alpha 1 through alpha 5, must hold, and you show that each of those 5 options would lead to the conclusion gamma, then you could conclude that gamma must hold. Well, now consider the second premise, that there is someone that James loves. That can be seen as like a big disjunction. It's saying that someone in the domain is loved by James, so it's effectively asserting that either Alex is loved by James, or Bob is loved by James, or James is loved by James, or Magnolia is loved by James, and so on and so forth, to the point where we have a disjunct for each and every member of the domain. If a conclusion follows, no matter which of those disjuncts is true, if it follows from each and every one of those disjuncts, then we're entitled to draw that conclusion. So we're going to show that we're entitled to draw the ultimate conclusion at issue, that Magnolia loves someone, by showing that it follows no matter which disjunct is correct. Now, of course, we can't do that by actually running through the proof for each disjunct. In that case, our proof would never end. So we're going to pick one disjunct in particular to focus on. And as long as we're careful about which one we choose to focus on, we should be good. So let's suppose that James loves Alex. Alex seems like a safe pick here, since there's nothing to distinguish him from anyone else. It's not like in our proof we've already assumed some things about Alex that we're not assuming about others. Then we continue our reasoning as follows. Since anyone James loves, Magnolia also loves, we can conclude that if James loves Alex, then Magnolia also loves Alex. So by modus ponens, Magnolia must love Alex, hence Magnolia loves someone. So assuming that James loves Alex, it follows that Magnolia loves someone. Now, crucially, the conclusion that Magnolia loves someone is a conclusion that we would have been able to derive no matter what we had assumed at the beginning about whom James loves. For instance, if we had instead assumed that James loves Bob, then we could have reasoned anyone James loves, Magnolia loves, so if James loves Bob, Magnolia must love Bob. Hence, Magnolia loves Bob's, thus we again get the conclusion that Magnolia loves someone. Because the conclusion that Magnolia loves someone is a conclusion that we would have been able to derive no matter what we had assumed at the start about whom James loves, and we know that James loves someone, then that conclusion follows outright. we're entitled to write it back in our original column of reasoning. Thus, the existential elimination rule allows us to do precisely that. Now, there are two main ways for this type of reasoning to go wrong. The first is that the person we choose to focus on at the start, in our example we chose Alex, is not just an arbitrary member of the domain, and so the conclusion that we ultimately reach is not a conclusion that we could have reached no matter whom we had chosen. Let me illustrate with some examples. So first, let's go back to this example. But this time, imagine that we suppose that James loves Magnolia. Then we reason as follows. Anyone that James loves, Magnolia loves. So if James loves Magnolia, then Magnolia must love Magnolia. So by modus ponens, Magnolia loves Magnolia. Hence, there's someone that loves themselves. The existential elimination rule would not allow us to draw that conclusion outright. That conclusion that someone loves themselves is not a conclusion that we could have derived, no matter what we had assumed at the start about whom James loves. True, had we assumed that James loves James, we still could have derived this conclusion. But not if we had assumed that James loves Alex or that James loves Bob. The problem here is that by assuming that it was Magnolia that James loves, we focused on someone special, someone who's explicitly mentioned in one of the assumptions that is in play. We didn't pick just some arbitrary member of the domain about whom we're making no other assumptions beyond the mere fact that they belong to the domain. And that allowed us to derive a conclusion that we wouldn't have been able to derive in all cases. Here's another example. Suppose that we have the premise for all x, there is a y such that Lxy. Everyone loves at least one person. Now let Alex be some member of the domain. From the premise, we can conclude that there's someone that Alex loves. So far, so good. That existentially quantified statement can be seen as like a big disjunction. It can be seen as saying that either Alex loves Alex, or Alex loves Bob, or Alex loves Carla, and so on. So if there is a conclusion that follows from each one of those disjuncts, then we can derive that conclusion outright. But now imagine that in our attempt to show that a certain conclusion follows in each case, we decide to suppose that it's Alex that Alex loves. From that assumption, it would follow that someone loves themselves, but we're not allowed to draw that conclusion outright. Because the conclusion that someone loves themselves is not a conclusion that we could have derived, no matter what we had assumed at the start about whom Alex loves. It's a conclusion we are able to derive only because we assumed that it was Alex whom Alex loves. If we had assumed it was Bob, or Carla, or Delia, or anyone else whom Alex loves, we wouldn't have been able to arrive at that conclusion. What went wrong is that by assuming it was Alex whom Alex loves, we again focused on someone special. We picked someone that bears a relation to Alex, the relation of identity, that other members of the domain don't. Now, the simplest way to avoid picking someone special is just to pick someone entirely new to the proof. Make it someone who isn't mentioned at all in the proof so far. That way, the only information that you have about them is just that they are a member of the domain. So that's what the existential elimination rule requires you to do. It says to start by picking someone not mentioned at all in the proof so far. Now, the second way for this type of reasoning to go wrong is this. Even though we focus on some arbitrary person at the start, the ultimate conclusion that we reach is specifically about them, and so it's still not a conclusion that we could have reached no matter whom we had chosen. Let's illustrate with another example. So go back to this example again, and let's again assume that James loves Alex. That's a good choice. Alex is entirely new to the argument, not mentioned at all in the proof up to this point. But now suppose that we reason as follows. Anyone whom James loves, Magnolia loves. So if James loves Alex, Magnolia must love Alex. Thus by modus ponens, Magnolia loves Alex. And now we try to draw that conclusion outright. The existential elimination rule doesn't allow us to do that. The conclusion that Magnolia loves Alex is not a conclusion that we could have derived no matter what we had assumed at the start about whom James loves. This is a conclusion that we were able to derive only because we assumed at the start that James loves Alex in particular. Had we assumed it was Bob or Carla or anyone else from the domain that James loves, we wouldn't have been able to derive this same conclusion. The problem is that our ultimate conclusion is specifically about Alex, the person we chose to focus on. That's why it's a conclusion we wouldn't have been able to derive in all cases. So this is something else we have to avoid. And we avoid it just by stipulating that your ultimate conclusion cannot specifically mention the person you chose to focus on at the start. That's another requirement of using the existential elimination rule. So ultimately, the existential elimination rule says the following. If you have an existentially quantified statement, and you pick someone entirely new to the proof, and supposing that they satisfy the existential, you're able to derive a conclusion that does not mention them at all, you can derive that conclusion outright. So for a last example, let's suppose we have the premise for all x, if there is a y such that Lyx, then hx, anyone who is loved is happy. And suppose that we also have the premise for all x, there is a y such that Lxy, everyone loves at least one person. Now, the second premise is compatible with there being lots of people that are unloved. It's even compatible with there being only a single individual that's loved. It could be that everyone loves that one person. So the premises don't entail that everyone is happy, because the second premise is entirely compatible with not everyone being loved. But in order for the second premise to be true, there does have to be at least one person who's loved. So there does have to be at least one person who is happy, given the first premise. So let's derive the conclusion that there is an x, hx, from the premises. We can reason as follows. First, let Alex be some arbitrary member of the domain. The second premise tells us that everyone loves someone, so we can conclude that there's someone that Alex loves. Now, given that someone's loved by Alex, we should be able to conclude that someone is happy. But to do that, we need to make use of the existentially quantified statement that someone's loved by Alex. So we pick someone entirely new to the proof, like Bob, and we suppose that they're loved by Alex. That implies that Bob is loved, and since we know that anyone who is loved is happy, we can conclude that if Bob is loved, then Bob is happy. So now we can conclude that Bob is happy. Now, that conclusion, of course, specifically mentions Bob, so that's not a conclusion we could have derived, no matter whom we had assumed to be the object of Alex's love. But from Bob is happy, we can conclude that someone is happy, and that conclusion no longer mentions Bob. That conclusion that someone is happy follows no matter whom we assume to be the object of Alex's love. Since whoever we assume that to be, it would follow that they are loved, and hence happy, and hence it would follow that someone is happy. So the existential elimination rule allows us to draw outright the conclusion that someone is happy.